that. All of this technology came from Europe, as you'll see in just a minute. But this second generation, the vast majority of these condensing boilers are one heat exchanger. To begin with, they had a standard heat exchanger with a condensing heat exchanger, 2 steps. The vast majority of them today have gone to 1 step with one heat exchanger. These are smaller modules. Vast majority of them are stainless. The controls are much more simple than they used to be, and they really can be pants laid together, and they're very reliable. We're there. For the condensing second generation boilers, we're there. First cost is coming down, highly competitive with non-condensing. Let's take a quick look so you understand the difference in the old-fashioned non-condensing boilers and how you ran them in efficiency and the new ones. This is important from an application standpoint to get this. So the light green there would be the old non-condensing boilers, and the top dark green would be the condensing boilers. And as you see, this is a plot of boiler capacity, boiler fire rate versus efficiency on the vertical left-hand axis. And you note that the old constant temperature boilers basically had the peak efficiency 100% fire. In this case, 71, 72%, which is probably pretty real. But look what happens as I reduce the fire rate on the old boilers. They start deteriorating around about 50%. The efficiency starts down. So at 20% fire, I'm down to 60, 10% down to 50. And this is fairly typical of the old boilers that did not have control of the air properly. Let's go to the top now to the condensing boilers. Condensing boilers, dark green. Remember that heat exchanger size doesn't shrink, and we're going to match gas and air together. So as I reduce the fire capacity on a condensing boiler, top green line, what do you see? You see the efficiency moving up at part load. All the way down, we're at about 10% fire. I'm up to 97, 98 points. I'm going to repeat this point to you many times in the next few minutes, so please don't misunderstand what I'm trying to do here. I'm trying to make sure you understand the fundamental application of condensing boilers would suggest to you to run multiple boilers versus one. The old boilers, we ran 100% fire. With a condensing boiler, you'd rather have 3 at 33% than 1 at 100. You'd rather have 2 at 50% fire than 1 at 100, because by going to 2 at 50 or 3 at 33%, you're going to have a much higher efficiency. 4 or 5 points you can pick up by simply staging your boilers properly and loading them properly. In the old days, we went 100% fire for falling over and on. That was the thing to do. Not anymore. So you got to change the way you think. You want to run a condensing boiler at part load if you can, because you're picking up efficiency.